Hello, it's James here. It's part 7 of openDog, the open source dog robot. Check out the previous parts for some explanation and the development so far. Obviously, we've got most of the mechanics together here. It is an open source project, and you can find the CAD for this in the link in the description below, and some of the early code that I did for the R&D and some explanation in those early videos, which are really important to watch. Today, we're actually going to put the motors on the legs and hopefully install all of the electronics, and that'll leave me clear in future episodes to do all of the coding. The only extra thing I've added already since last time are these pieces on the outside of the shoulders, and these bind together the 10mm studding with the 30mm tube to stop any bend between them. There was still a bit of skepticism in the comments from last time as to whether this bit of 10mm studding would be strong enough and wouldn't bend, because obviously it's holding the rods there and the whole weight of the robot, but as I showed last time, you can put considerable force on top of the robot without it bending, and that's because this is a square. There's 2 of these rods here. If there were 1, obviously it could bend, but because there's 2, it's held in a square. It can't bend unless the 30mm steel tube bends, which is unlikely unless it bends in these plastic bushings, and we can replace those with metal, but at that point, pretty much that will require quite a lot of force. I've also added a steel collar here which holds the leg, and basically that stops the leg sliding up and down on that tube even though it's pretty tight. Right, we've got 8 more motors here for the legs, 2 on each leg. These are the Turnigy AeroDrive 149 kV motors, the 6374s of course, the same as the other 2 actuators. These are our motor brackets and encoder mounts. Obviously on the back we've got that bit of studding that goes through this bearing, and that's where the encoder mounts to measure the position. For now I'm using PLA motor mounts, the same as the other 4 actuators. If it turns out the motors get too hot and they melt, then we'll just make some metal ones. So I've fitted my 2 motors on their brackets there. Each one of course drives a pulley which will drive the ball screw. I haven't fitted the belts yet, although they are the right length, and that's because I need to calibrate the ODrives for the encoders against the motors to get those encoders in the right position for the motor stator position so it can control them properly. There's obviously the mount on the back there, which is where the 2 encoders go, that I haven't fitted yet either. Now these are in the most bulky position as I originally designed. There was talk about putting them in line with the ball screws, but for now I'm going to do that. I know I've got a 2:1 gear ratio. That gives me lots of power. It makes the leg really big, but you know, they're quite modular. We could take them off and change them around in the future. I fitted the motors on the front legs. You can just about see them poking out there. It doesn't make it much wider than these anyway, so that's pretty good. Still got to do the back legs. I'm just waiting for those pairs of brackets to print. So I mentioned last time putting the electronics on these 2 parallel rails I've had cut to length, and I've printed these brackets to hold them. Right, I've 3D printed this battery box as well, which is 2 halves and a central thing, and that's going to bolt in just in the middle there, in between the 2 sets of legs. So in between those battery pockets, I've got space for 6 batteries. There's only 2 at the moment. We've got this power distribution thing, which is a load of bolts, and at the bottom those heads are shielded there, so they don't short out on the extrusion, and we're going to have lots of terminals that go onto there, and that takes the power off to all the ODrives. At the moment I'm going to run it on 24 volts, and I've got space for 6 24-volt batteries. We could series those up in the future to make sort of pairs, 48, 48, 48, and I've bought the 48-volt ODrives. So this is what we're going to eventually end up with. We've got lots of things on our rails there, which are sort of in a card slot system, so that we can see what's going on and sort of run wire up the channel there each side. So there's a few things there. There's some Arduinos, there's some power, there's the ODrives that get mounted at each end, and there's also a control panel. But let's get some of those ODrives mounted and see how the space looks. Right, we've got 6 ODrive 3.5s we're on now. They come with firmware on, which is pretty good, so you don't have to do that yourself. These are the 48-volt version, which means I can run up to 36 or 48 volts if I want. I'm probably going to start on 24 as I say, and it's 24 volts I did the testing on. So let's put those in and see how they fit. So in terms of spacing, the power wires drop straight out the bottom, power comes in the side here, so there's plenty of access there. We just need to make sure we can plug into the GPIOs and so on with these connectors, but I think that's adequate spacing, so I might cut a little bit off the end of these rails so they don't come right to the end of the robot. We can put a 3D printed piece on that slopes there, and maybe in the future we can put sensing and things in that space. So there's also, as you'd imagine, some Arduinos. We've got the initial Arduino, which is the one that's got the Bluetooth interface on that talks to my remote that I was using early on for the early bits of kinematic calculation and driving the ODrive. That's going to be my master. And then I've got two others which are slaves, and that's because I need so many serial ports on all of the ODrives. So what would be ideal, of course, is if we could just have one really powerful master controller and we could link all the ODrives to it, and that would be the solution. And there is actually a CAN bus interface on the ODrive. It's just unfortunately it hasn't been implemented in firmware yet, so I can't actually use it unless I was to write that bit of ODrive firmware myself, which I don't fancy doing. But at the time of recording, it's not implemented. In the future it will be. There's also plans for a UART to CAN bus bridge, so I could go serial in from an Arduino to one ODrive and daisy chain the rest together, and that'd be really good. But that hasn't been implemented yet, so what we're going to actually do is just use the serial port, because that's all we've really got. So we need 6 serial ports. Each Arduino Mega has 4 serial ports. So that's more than enough to receive serial data, talk to the others, and if we use one software serial, we'll even get a spare one for diags. So that's my plan, and that's why we've got these 2 Arduino Megas. All they're going to do is take serial data from the master and then basically relay it onto the ODrives. They might do some other things like deal with the homing, because that's the other thing that hasn't been implemented in the ODrive firmware. We've got no way of homing to a home switch and then zeroing the encoder position. So again, I need that Arduino, which is going to basically go and take care of that, go and look at the encoder position and take that away from the rest of the data so it maintains its 0 position. And in doing that, it gives us a very useful feature, which is that the Arduinos, these 2, can basically keep that 0 position all the time. And then even if I reboot my master Arduino, my master controller, whatever that turns out to be in the future, then that won't lose its 0 position because it's not in charge of keeping hold of it. So that means I can keep making lots of program changes and I don't have to home all my actuators every time I boot it up. So those 3 Arduinos are going to live in there. As I say, the master one is probably temporary. For now, it's more than capable of dealing with the kinematic model, the trigonometry, because I've already done most of it. The other 2 are the serial relays. And of course, the ODrives actually deal with the PID controllers and counting the encoder revolutions. So there's not much load really on these Arduinos at all. Eventually though, I will take out the master and we'll replace it with something else, and that may well be an actual computer running a Linux distribution, because I've left enough space between the rails here for a mini ITX board to fit, and that's one of those tiny 17 by 17 centimeter square boards that we can actually run a proper Linux distribution or Windows if we wanted, and then we could plug in a Kinect sensor and various other things like that and do image recognition and so on. So I've got one last peculiar board, which is actually a USB power bank, and that's going to provide power with a separate switch there. That's 5 volts for all of the Arduinos and everything. So the ODrives actually have their own power regulation from the battery. I probably could take 5 volts off them, but at least this way I can reset the electronics or whatever I want to separately. So with those cards all installed, that just leaves the control panel, which I've already made here. So we've got various things on here. We've got a voltage monitor, we've got a big emergency stop, which is actually going to pull the resets on the ODrives high or low, or whichever way resets them, so they're incapable of moving the motors. We've got an LCD, which is one of those with the I2C piggyback, same as on the remote, so we can display various messages from the master controller. We've got a number of switches, which I haven't decided what they do yet, but I thought I'd put them on because there was space. And we've got some other buttons here, which are actually illuminated switches. And you'll notice there's 4 on each side here. And basically that's for the 2 sides for the 4 legs. And basically we're going to be using those for homing the various joints. Probably these ones will home the legs swinging in and out, and the others will home the other 2 motors. As I say, they're illuminated so they can flash and so on, and tell me to press them in turn, and we'll home each leg in turn, and basically I can hold the whole robot in the air while we do so that the legs are free to move. Well, it's not the most efficient use of space. Obviously there's quite a lot of space around all these cards, but we do have quite a lot of wiring to do. I could pack it in much tighter, but it makes it quite easy to see what's going on, and I can take bits and pieces in and out or add extra modules if I need to. We could also go for a double deck here if we wanted more stuff. And we could probably get some stuff on the ends, and there's plenty of places for sensors and things like that. So I've wired in some 5 volt power distribution just to the Arduinos there, and so if I press this on and turn this on, you should be able to see the Arduinos nicely glowing away there. And also the display comes on because we've got power to the control panel. There's no data yet, so it doesn't say anything. And you'll see what I've done with each of these is left nice loops of wire on Velcro so that I can pull these wires out, and we've got loads of slack there to come and work on it. then we can fit that back in there, and there's a little Velcro tab there. So we can just poke that wire back in and leave it all nice and tidy, and we should be able to run all the wires down this channel eventually. The control panel's actually got a connector on. I've got a 25-way D range, and I've wired in lots of things on the back of that. So obviously every LED for each of these illuminated switches, and also the actual logic connection for the switch connection, the I2C in power for the LCD, the other wires for various things including the emergency stop, and all of those go to this 25-way D range connector, so the whole control panel comes off. And the connector is on the other side. Just plug that back in. So that means there's loads of slack again on the wires. There'll be a big sort of rope of wire there, and that goes to the other side of the control panel, so I can take it off and work on it, and I can still leave it connected. So there's quite a lot to wire up. I'm just wiring in the serial wires that go from the master Arduino to the slave, the control panel wires, so we've got the I2C for the display coming all the way through to the master Arduino, and these are for all of those illuminated switches for the switch function and the LED, and basically half the wires will go to one slave Arduino and the other half will go to the other one. So these are actually going to deal with the homing of the robot, of those actuators, and that's what those switches and LEDs are for. Right, I've just written a little sketch on that master Arduino that's making the LCD work, just to check my connections are good, and you can see it's actually counting up there, and that's counting on each code loop, so we can see the code is running. It's also sending that data back to the remote, so if I plug in and pair my remote up, we should see waiting to pair Bluetooth, paired, and we see exactly the same number, even though I've only just turned the remote on. And that's because the actual robot is doing the counting and running the code loop and sending the data to the remote, and that's how we can tell wherever we are that the code hasn't frozen. I've also got a menu that works still, and this was very early code from part 1. The code's still up on GitHub, but that mode is in fact running on here as well, and sending that mode stuff back to the remote. So basically whatever I do here, if I go to 5 and unplug this and plug it back in again, just wait for that to pair again, and we can still see it's still in mode 5 in fact. So all of that's kept actually on here, and effectively the remote is a dumb terminal. I've also written some simple code on both the slave Arduinos, and remember those are going to control the O drives directly, so on power up we need to home them and get those to the limit switches to get the 0 position. So you'll notice there's 2 lights on here now. What'll happen is I'll pick up one end of the robot, press this switch ready to home the first actuator, which will probably be the ones that bring the legs in and outwards, and then it will home it, then it'll go on to the next one, that'll do the other leg. Then that one will home both the motors, both for the shoulder and the elbow, and the same thing, and it'll do that on both of them. And when it's done, it'll then allow me to send commands from the master Arduino to position them, and it'll probably lock it out before that for safety. So we need to talk about the limit switches. So this whole system is encoder driven, so it's very accurate at tracking the position of the motor, but obviously it doesn't know where it's started up. So first of all, we have to drive all the actuators to the end, a bit like with a 3D printer or a CNC machine, and basically find where that is. So I fitted a micro switch. It's on a 3D printed block. At the moment, it's just taped onto the sort of bearing block that holds the ball screw with some double-sided tape. It's pretty tough double-sided tape. I'm hoping there's not going to be too much force on it, so that should be strong enough just for it to be pressed. It's right at the end of the mechanical limit. And then we're going to have a block that's glued on to the thing that slides up and down. So you can see that is the ball screw thing moving there, and that's going to be fixed on there, and that's going to press the limit switch when we get to the end. And I'm going to make sure that it can't physically go any further so we don't break the switch off. But that should be sufficient for homing, and obviously we'll wire in this limit switch to the slave Arduinos, and those are going to basically record that 0 position and keep track of it. So each of the 6 O drives now got some wires attached. We've got the serial RX and TX, which go to GPIO pins, a ground pin, and the reset pin. So I need to daisy chain all the grounds, daisy chain all the resets that go to that red mushroom on the control panel, and then the RXs and TXs, each of them go to those slave Arduinos. So in groups of 3 O drives, going to the 2 Arduinos, 3 on each. So I've wired in all my O drive, the ground, the serials, and the reset pins, and the blue and yellow wires are the serial, and those go over to the 2 Arduinos, and obviously the same on the back as well. I fitted my encoders. Obviously there's 12, there's 1 for each motor. I've got cables which O drive provided, which are made up for those, so they just click in there. We can strain relieve the cable down here, and we need to run the other end to the O drive. The cables provided are 2 meters long though, so they're far too long. We need quite a bit of slack here to come around in a nice S shape. so that the leg can move, but we don't need the extra meter on the other end. So I'm going to basically allow enough to be strain relieved and shorten these and just basically resolder the pins on this end that plug into the ODrive. On this end of the cable we've just got pins, so I'm just going to get some right angle pin strip, which is how I attach pins to Arduinos and things, cut this cable shorter, put a right angle connection on, then we can get into the top of the ODrive here and just plug those in. I managed to find yellow conduit with the split in so I can get the wires in, so we're going to run that round in an S shape there, so the leg's free to move because that's really flexible. It's constrained at each end with a special block here, and on the knee here I've made a special bracket that brings this round at an angle so it avoids the pulleys here, so we can bring those wires out to the leg here. So I've wired in my in switches and my encoder wires, and all those wires go up the conduit. So we're right underneath the robot, and there's another end switch there for these actuators, so let's just zoom in on that. So you should be able to see another micro switch. I just need to wire the wires in, and that hits this thing as it slides on those linear actuators underneath the robot. And the wires from all those end switches just come up here for now, so these need to go to the two slave Arduinos so they can deal with the homing sequence. Well, all of that's wired up. There's obviously quite a lot of wire in here, and we actually haven't put the power in yet for the ODrives or the motors, so we've got all the 12 actual motors to wire up and all the power that powers those 6 ODrives. Right, so loads of red and black wires hanging out now. These are the motor driver wires, so 36 wires, each with a 4mm bullet connector soldered to it, and those all run through the conduit and up from the chassis for the 2 motors below. And we've still got to run actual power to the ODrives from that power distribution thing where we started the video. So I'm just making up power connectors here for each battery with these crimps on to go on my 8mm studding. We've got 4 bolts here, and I'm making 2 positive and 2 negative, so we've got these loops that link the 2 negatives and the 2 positives together. Then our battery connectors go on, and eventually there'll be another 4 of those because we're going to have 6 batteries. So we'll basically take 3 onto the front and 3 onto the back, and then we'll run the ODrives off those as well. So we've got lots of power wires coming out of the ODrive. Obviously there's 3 ODrives and 3 lots of wires going to those motors. You can maybe just about see the power distribution coming into the side of the ODrives for their actual power, which of course comes along to the power distribution thing in the middle. So all my wiring's fitted in there pretty neatly. There's quite a lot of wires, but at least I've got slack so I can get those cards out. All of it should run in the channels down the sides here, and all of it should run under those rails, leaving them free for more instrumentation to be mounted. So my ODrive is powered up, and I've used the Arduino script that's provided by ODrive, so you can see that I've now got my motors, I've got holding power on. It's only on very low current. I haven't connected the belts yet because we need to do some motor calibration, but we can see that that will go back to where I left it because it's got the encoder, and we can also run a test move on those motors. You can see those running at different speeds using the encoders there for positioning and speed control, so that seems to work, and it works on all of the motors. So if you go to the ODrive Robotics website and scroll all the way down to the bottom and go to the Getting Started guide, there's quite a lot of documentation here about setting the ODrive up and doing everything you need to. There's also the GitHub for ODrive, which has the Arduino code on, so there's some example code there. Basically, which is the code I'm running, so I'm not going to be putting this up separately because it's pretty much exactly this, although of course I'll be using that as a basis for my code on those slave Arduinos. Okay, so that's everything wired up for the robot, and we're ready basically to try and write code, at least starting on those slave Arduinos, to get the ODrives running, to go and hit those end switches. Then we can put the belts on and we can basically get those actuators running, and then the next thing will be to get the master Arduino to send code to the slaves to try and control all of the motors at once. But that's quite involved, so that's coming up in the next episode. For this episode, I'm not really going to put any code up because there isn't really anything apart from that button and LED test code, which isn't very exciting. And obviously I'll be building that code out next time when I'll start publishing proper code for the whole robot. I have, however, put up the complete Cad Assembly as a solid model in step format, which means you can easily modify it, not like an STL, it's actually a solid model. So I've put that up on the GitHub, have a look in the link in the description below, and basically that's pretty much all of the CAD, I think, until I start adding other accessories on. So thanks again to patrons for supporting this project. Have a look at patreon.com/XRobots, and you can get access to some exclusive rewards, including the videos early and sneak peeks of other projects, and also a live stream with me. That's all for this episode. Don't forget to subscribe for more update on this project and all the other projects. Alright, that's all for now.